A warm welcome, dear students. It's me, Gayathiriedumath, tutoring math for class 10, CBSE and ICSE students. In my channel, Gayatri Edumath, a smart way to learn math. Moving forward, with 12 plus years of teaching experience and my urge to help student community, I launched my channel on 1st February 2026. I posted my first video on 16th February 2026 for ICSE students on similarity as a part of revisions. Now, I would like to extend this support to CBSE students as well. I will be posting solutions to CBSE NCERT and ICSE ML Agarwal books too. Now, this will be CBSE series chapter 1 NCERT real numbers.
Let us start with the first chapter, real numbers. Real numbers definition, we'll just go through a few concepts, children. Concepts are very important. We'll start with the first concept, real number. Real numbers are numbers that can be represented on the number line. So this is the number line. So this is 0, minus infinity, plus infinity. So we have in the number line, we have positive numbers towards your right, 1, 2, 3, 4 and so on. And towards the right, left you have minus 1, minus 2, minus 3, minus 4 and so on. So here you have whole numbers starting from 0, 1, 2, 3, 4, natural numbers starting from 1, 2, 3, 4, integers starting from there towards the left, minus negative numbers, minus 2, minus 1, minus 3, so on, and positive numbers 1, 2, 3, so on. And rational numbers and irrational numbers I will be explaining to you in the later half of this concept. Okay, this is the number line. These are called real numbers. Moving on to prime numbers. Prime numbers are numbers where you have factors, two factors, that is 1 and the number itself. Okay, so first we'll start with 2. Now 1 is neither a prime number nor a composite number. 1 is a unique number. 1 is a unique number. It is neither a prime number or composite number. And 2 is the only even prime number. No other numbers other than 2 are prime. Only 2 is the prime even number. Okay, you might get this in any definitions or any 1 mark MCQ in any other aptitude test or something like that. One even prime number is only 2. Okay, so now for 2, if you see, the factors are 1 and 2. So there are only two factors, 1 and 2. So this is a prime number. So next number 3. The factors of 3 are 1 and 3. So we have 1 and the number itself, so it is prime. So next number we can see 4. What are the factors of 4? So 2, then 1 and 4. So numbers 1 and 4 are factors. Apart from that, you have another factor 2. So you have more factors, more than 2 factors you have. So it is a composite number. So next number 5. So the factors are 1 and 5. So only 2 factors, 1 in itself, so it is a prime. Next number 6. So you have factors 2, 3, 1, 6. So only 1 and 6 are prime factors. Other than that, you have 2 factors, 2 and 3. So this is a composite number. So like that, you can just list the numbers and just check whether they are prime or composite. So numbers will be either prime or composite. Only one number 1 is neither a prime nor a composite. 2 is the even prime number. Only even prime number. Okay, next. Rational numbers. Rational numbers are numbers that can be written in the form a by b. A by b and b not equal to 0. Okay, that is always in a number the denominator should not be 0, should not be equal to 0. Otherwise, it becomes undefined. Okay. So it should not be, and where a and b are integers, when b not equal to 0. It can be integers means positive and negative. Okay. Now we go to irrational numbers. Irrational numbers are numbers that cannot be written in the form of a by b. It cannot be written as a fraction. Same way, the only difference is cannot be written as a by b form. and A and B are numbers and B not equal to same. Its decimal expansion is non-terminating and non-repeating. Okay, it is non-terminating and non-repeating. That is, when you have the value of root 2 and root 3, what are the values of root 2? So the value of root 2 is 1.41421 and so on, and value of root 3 will be 1.73205, so on. Okay, so these are non-terminating. Non-terminating means they don't terminate, and non-repeating, they don't repeat also. So non-terminating and non-repeating, they are irrational numbers. So non-terminating, this they don't end. No ending and no repetition. No ending. Repeating is they don't repeat also. Repeat. No ending, no repeating. Okay. So these are irrational numbers. Now Euclid's division lemma. Suppose now for any two positive integers a and b, there exists a whole number q and r such that q is the quotient and remainder. Okay, this is the format. A is equal to bq plus r, where r is greater than or equal to 0 or less than b. Just I'll give you one example. We'll take the same example, 50. I am dividing this 50 by 4. Okay, that is 50 divided by 4. Okay, now 50 means 12s are 48. Then if I subtract, I will get the remainder 2. Now this is A, this is B, this is Q, and this is R. Okay, so A is equal to BQ, B into Q, that is 50 is equal to B into Q, 50 is equal to B into Q, that is 4 into 12 plus the remainder 2. Now this they are telling for the remainder. Okay, so for the remainder will be, that is 2 will be greater than equal to 0. The remainder will always be greater than 0 but less than b. Less than b is less than 4. Okay, so see, just imagine here you have the remainder 2. The remainder can be 0. Like sometimes if it is exactly 48, it will be 0. Then 49, it will be 1 remainder. For 50, it will be 2 remainder. For 51, it will be 3 remainder. For 52, you will not get remainder 4 which is equal to 4. You will increase this number. Quotient will increase by another next number. So this number will always be from 0. It can be 0, 1, 2, 3. It cannot be 4. It cannot be 4. Okay, it cannot be 4. So it will be from 0 to 3, less than b. B is here, b is 4, so it is less than b. So it is less than 3, that is less than 4, that is 3, 0, 1, 2, 3. Okay, this is the concept. So 50 is equal to 4 into 12 plus 2 remainder. Okay. Yes, fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime numbers, and this factorization is unique. That is, every number will have a prime factor, different prime factorization. Suppose this is 18, 2, 9, 3, 3, 1. So the prime factorization will be 2 into 3 into 3. So this is the factorization for 18. So 18 is equal to 2 into 3 into 3. 27 will be 3, that is 9. Again 3 3s are 9. So for 27 it will be 3 into 3 into 3. So here they are saying that they have each number can be expressed as a product of prime numbers. These are all prime numbers. 2, 3 and all these are prime numbers, and this factorization is unique. For each number, the numbers, the factorization numbers will be different except for the orders. Orders is the multiplication order can be different. I can write 3 here, I can write 3 also in the beginning because 18 goes in 3 also. Okay, so the orders may be different because in product the order is not important. It can be in any order. In addition or multiplication order can be anyhow, but you will get the same result. So that is the meaning of except for the order of factors. So every composite number can be expressed as a product of prime numbers, and this factorization is unique because each number has a different number factorization number. The numbers will be different. Okay, so this is the concept of real numbers. So learn the terms and concepts in the beginning of each chapter well, so that when I am telling in the chapter, when I am talking about real numbers or for irrational numbers or irrational numbers, you should be very thorough and you should be confident, because CBSE is based on concepts. When you be thorough with your concepts, and if they change numbers and give also, you will be able to do the sum. Okay, we'll go to exercise. Express each number as the product of its prime factors. So for sum, 140. So 140 is a even number, so it will go by 2 first. So 140 is an even number, so 17 will go 7 times and then a 0. So again 70 is a even number, we will go by 2. So 3 2s are 6, carry over 1, and 5 2s are 10. This is a number ending with 5, so we can put it by 5. So 7 5s are 35. 7 is a prime number, so it will go once. So the factorization 2 into 2 into 5 into 7. We can write it as 2 squared into 5 into 7. Okay, next number 156. 156 is a even number, so 2 times, so 7 2s are 14, carry over 1, 16 will go 8 times, 78 again is an even number, 3 2s are 6, carry over 1, 9 times, 9 2s are 18, again this number 39. When you want to check for 3, for 2 it is an even number, for 3 when you add the digits and the number is divisible by 3, then it is divisible by 3. So you have to add the digits, add the numbers and see, not the digits, numbers. 3 plus 9 is 12. 12 is divisible by 3. So 1 and 3 times. 13 is a prime number. So 13 into 1, that's all. So 2 into 2 into 3 into 13. So 2 squared into 3 into 13. Okay, next sum. 3825. 3825. So the number is ending with 5, so we will go with 5. So 38 means 35 7 times, carry over 3. 32 means 6 times 30, and remainder 2. 25 means 5 times. Again it is a number ending with 5, so 1 time 5 and then remainder 2. Okay, so 5 times 25 and 1 time 3, 153. Now it's not an even number, it does not end with 5 also. Now next we'll check with 3. Just add the numbers and see. 1 plus 5 plus 3 is 8, 8 plus 1 9. 9 is divisible by 3, so we'll just divide by 3. 9 will go, so it is 15, it will go 5 times. 3 it will go 1 time. 51, again 5 plus 1 6, it will go in 3. So 1 time, 3 balance 2, 21. So it is 7. So 17 is a prime number, so we'll write 17. So it is 5 into 5 into 3 into 3 into 17. So it is 5 squared into 3 squared into 17. Okay, next part. 5005. Now this is ending with 5. So it is 1001. Now this is not an even number. This will not go in 3 also. When you add 0 and 1 and 1, it will be 2. It will not go by 3 also. It will not go by 5 also. So we'll just check for 11. How to check for 11? Suppose the numbers are like this. Okay, we have to take sum of even digits and odd digits. This is odd, first one and third one. This is even digits. So 0 and second and fourth. So when you find the sum of this 1 and 0 and 0 and 1. This is 1, this is 1. The difference of the sum of the even numbers, the concept is like this. Difference of sum of even digits and odd digits. Okay, so you have to take even digits and odd digits like this. Where you add the one on top and add the one on the bottom and find the difference. The difference should be either 0 or multiples of 11. Multiples of 11. So it is 0. So the number is divisible by 11. So I will take 11. 11 is also a prime number. So we will take 11. 100 means 99. 99 will go 9 times. Remainder 1. So 11 it will go 1 time. Okay. So 91. Again 91. It's not 2 even number. By 3 also it will not go. By 5 also it will not go. We will just check for 7. 7 means 7 ones are 7. Remainder 2. It is 7 threes are 21, and then 13 is a prime number, 13 and 1. So it is 5 into 11 into 7 into 13. Okay. Now the last sum, 7429. 7429. Just add these numbers. It does not go in 2, 3, 5, 7, nothing. These are all, we have taken all prime numbers, that is 17. Okay. So 17 it will go by 437. Then by 19, just check all the prime numbers, students. 2, 3, 5, 7, 11, then 13, 17, 19, 23, like that we have to check. Numbers does not go in this set, then till this we have checked. Then again you check for this 13, 17, 19, 23, like that. Okay, then it will go in 437 23 times. And again 23 is a prime number, 23 one time. So the number is 17 into 19 into 23. Okay, we'll go to the next sum. Now we have to take, we'll take the first sum. We have to find the LCM and HCF, and then we have to prove that the product of two numbers is equal to LCM into HCF. So first we'll take 26 and 91. Now we'll take the prime factorization of 26. 26 prime factorization of 26 will be 2 into 13. 2 into 13. So for 91 it is, if you want, we just write 91. 9 plus 1, 10. So it will go in 7. Okay, it will not go in 3, it will go in 7. So it is 1 time. So 7, remainder 2. So it will go 13 times. So it is 13 is a prime number. So 7 into 13. Now we will find the HCF. HCF means highest common factor. These are the factors. What is the highest common factor here? Common factor is 13 only. 2 and 7, they don't have other pairs. Only 13. Highest common factor. So it is only 13. So it is 13. Now LCM. LCM is, we will write all the factors once. If it is repeating twice, if it is a repeating number, we have to write it only once. So the factors are 2 and 7. 13 is getting repeated. We will not write 13 two times, we will write only once. Okay, so the factors are 2 into 7 into 13. 13 is a repeating number and we will take it only once. Okay, now we'll just write this formula here. Product of two numbers is equal to LCM into HCF. Now before we multiply, if you just see, these are the factors of 20, 26 and 91. So 2 into 13 into 7 into 13. Okay, here if you just see the factors, if you multiply all this, you will get the multiplication of these two numbers. So this itself we can just prove. So the product of two numbers will be 26 into 91, but we have to multiply and show. LCM into HCF is, LCM is 2 into 7 into 13 into HCF will be, this is LCM, HCF will be 13. Okay, just multiply and show. When you multiply these two numbers, you will get 2366. You have to multiply and show, children. You just not write this just for explanation. I told you, you have to multiply and show. This is also 2366. Just multiply, and this is basic multiplication. So hence, since it is verification, we'll just write the conclusion. LCM into HCF is equal to product of two numbers. Next sum. Next sum, 510 and 92. So for 510, what are the factors? 510 I'll do here. It is an even number. 2 times 4, carry over 1, 5 times. 10, carry over 1, another 5 times. It is number is ending with 5, we'll do it by 5. So it is 25 is 5, 5 is 1, 51. When it's not an even number, next check for 3. 5 plus 1 is 6, so it will go by 3. So 1s are, and remainder 2, 21 is 7 times. 17 is a prime number, so 17, 1. Okay, so number is 2 into 5 into 3 into 17. Okay, then for the number 92 is an even number. So 4 times, 4 2s are 8, carry over 1. So 6 times 12. Again, it's an even number. So 2, 23. 23 is a prime number. So 23 and 1. That's all. So it is 2 into 2 into 23. Now first we'll write HCF. So HCF will be, common number is only 2. Only 2 is the HCF. So LCM will be simple. Apart from 2, you write all the other numbers. This repeating 2 alone, you write once. So apart from, leave this 2, write 5 into 3 into 17. Okay, so leave this 2 and write the rest 2 into 23. This 2 times repeating number, write only once. That's all. Okay, now we'll write the statement, product of two numbers is equal to LCM into HCF. Product of two numbers will be 510 into 92. LCM will be 5 into 3 into 17 into 2 into 23 into 2. HCF will be 2. So this will be 46,920. This will be 46,920. Now hence, proved, product of two numbers is equal to LCM into HCF. Okay, we'll move on to the next sum. Third sum, third subdivision. 336 and 54. 336, the number is an even number, or we can put it directly by 3 also. 3, 1, 1, 2. Now this is an even number, so 5 times, remainder 1, 6 times. Now again even number, 2 times, and 16 will be 8 times. Again even number, 1 14 times. Again even number, 7 times. This is prime number, so 7 one time. So this will be 2, how many times? 1, 2, 3, 4. So 336 is 2 to the power of 4. 3 into 2 to the power of 4 into 7. Okay. Now 54. 54 will be, it's an even number. So 2 2s are 4, 1, 7, 27, 3 times. So it is 9, 3, 3, 1. So it will be 3 cube into 2. Now first we will write HCF. HCF will be 3 ones and 2 ones. So LCM will be the repeating numbers. We will write it as, we'll write it like what it is repeated. So we have written ones already, we'll write 3 squared. 1 is only repeating, so we'll write 3 squared. Again here it is repeating, so one time we have written, so we'll write 2 cube. We will not write the repeating thing, into 7. So we'll write product of two numbers is equal to LCM into HCF. So product of two numbers will be 336 into 54 is equal to LCM will be 3 squared into 2 cube into 7, and this will be 3 into 2. So when you multiply, you will get 18,144 is equal to 18,144. Just multiply and show. Hence proved product of two numbers is equal to LCM into HCF. That's all. Thank you.